Hey, hi everyone. This is Sai from LetsUpgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us, like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
Hi, welcome back everyone. In the last module, we have explored how operators help us with the data. Today, we are going to level up and learn how to make decisions in our Python programs. Oh yeah, decision making is where the magic happens. Imagine writing a program that can adapt, react, and make choices just like you do when you're deciding on what to wear based on the weather or what accessories to take based on the conditions outdoor. In programming, why decision making is important? Let us try to understand that. So, decision making is essential for creating dynamic and interactive applications, right? It's how you tell your program to do different things based on the inputs or data received at that instance. For example, an ATM needs to validate your PIN before it lets you withdraw the cash, right? Just try to imagine if these conditions are not met and the ATM is allowing you to withdraw money, such an hazardous or impractical situation that is, so that the security is compromised, right? Or we can also take an example of e-commerce sites which apply discounts based on your purchase history. So these decisions, whether this customer should be given certain amount of discount or what about discount or bargain should we do with this customer based on the record, based on the customer's interactions, is where decisions come into picture. So these are decisions, right? And today we will learn how to implement them in Python. So let me go ahead and share my screen to understand the basics of decisions. All right, let's start with the first conditional statement known as if, elif, else block. These are the basics of decision making in Python. Let's try to first absorb the syntax. So the syntax is as follows. If the given condition, if this is true, now it's a good time to recap what we learned in the previous sessions about indentation, right? That when I hit enter, you see by default now I am writing at level 2 intent, right? So this is where the code comes into picture, and once I'm done with it, I can go back to if there is one more condition. So if this condition is met, only in that case run level 2 indentation part of the code. Else, the Python or the program will never enter line number 2 if line number 1, which is an if statement, the condition is not met. Elif, there could be condition 2 for, let's say, elif. Let us say for if. So similarly, we could have numerous elif conditions coming into picture. Could be condition 1 and so on. Then there could be indentation for the final condition, which is else, right? This is just at high level how the syntax of the if, elif, else conditions would look like. Now, very soon we will try to learn it through one practical example. So let us write a code which uses this logic to implement if, elif, else loops. Let us take a number from the user. I will make sure that the input is coming into integer. Hence, the line of code which I'm writing, it mentions number is equals to integer, and input is the command which we have learned to take any input from the user, right? So number is equals to enter a number let us say from 0 to 100. And we will say if number is less than 10, we will print the number is less than 10. Elif, we will go to the elif block. If number is less than 50, we will say, or let us say if the number is less than 100, we will say the number is less than, or let us keep it 54 now. And if the number is less than 100, we will say print the number is less than 100. And then we will go to the final else block, else print the number is 100. So for now, we will keep the code very simple. We are just trying to demonstrate that the possibility of taking input is only restricted between 0 to 100. There is no scope that the user can give us any negative value or a number greater than 100. These values are by default restricted. This is something that we will take into consideration as an assumption for this code. And with this, we will proceed and try to run python sample.py. So as you see in the bottom of my terminal window, we have enter a number between 0 to 100. Let us go for 8. You see we get the printing that the number is less than 10. If I try to clear my window and again try to run this code, and this time I go for 60, I'll say the number is less than 100. Once again, if we try to run this code and give a number 45, you see the number is less than 50. I can also help you further understand by adding a debugger on line number 12, which is where the if statement is written. And I'll try to debug this code with you to explain you how the logic of if elif else works. So in VS Code, if we have to debug something, the shortcut is F5. We can always go to the run and start debugging. Okay. So in this case, the program will stop or halt due to artificial intervention known as breakpoints. Will put a red circle around the line we want to stop. Let us give it a number say 40, or let us say I'll give it a number say 99, and I'll say hit enter. Now you see, because of my debugger, the code has stopped here, and now we can visualize how this entire looping structure is supposed to work. So by now, if you see, my number variable, it holds a value of 99. So the condition right now is if number is less than 10. Now we know the number is not less than 10, hence if I click on step over, which is the method in VS Code to go to the next possible line in the code, you see it will not go on line number 13, it will directly go to line number 14, which is the elif condition block. Elif the number is less than 50, which is in this case also isn't, the expected behavior is for this code to proceed to line number 16 to the next elif block, and so it does. Now again the number is less than 99. So here the number is less than 99. So in this case, the expected behavior is to not go on the line number 18, but enter the elif block of number less than 100, and which is where you see that the number does enter uh, the same block as expected. And when we click next, you see the program has finished its execution with the output the number is less than 100, since there were no more part of the code left to run. So this is how we visualized how if elif else block is supposed to work. Now that we have fair idea about the if elif else block, let us understand the nested conditions, which is nothing but adding a little bit more complexity into the current understanding of our if elif else blocks. So what if you have multiple criteria to evaluate? That's where the conditions get nested, right? They allow to add layers into decision making, right? For an example, let us determine if a student is eligible for a scholarship based not only on their grade but also on extracurricular activities. So in this case, usually what we will do is we will take input as what is the grade. Please mention your grade, and we can take were you into sports activity, yes or no, and then we will be nesting the conditions. So let us learn, or let us implement how this type of code should work. I'll again share my screen. So let me take an input, say score, okay, is equals to integer. For simplicity, I will keep it integer. Please enter your score, uh, assumed between 0 to 100 again, which is like you can say, or also you can consider it to be a percentage or anything which you want based upon your condition in real life. We will take activities is equals to, we will again say integer input, press 1 if you were into sports, 0 otherwise. Now this is where the condition of whether we should give the scholarship will come into picture. So nested if else statements to decide whether a student is eligible for scholarship based on his or her score and participation in sports. So let us say we will write the first condition, which is like if. So the first mandatory condition to get a scholarship, let's say the condition is the student should have at least 75 percentage, or let us say 85 percentage in the curricular or examination. And over here, we want to have one more nesting, which is where the nesting will come into picture. So student has passed first layer of our decision making, that whether the student has score greater than equal to 85. For now, I'll just write a pass statement over here, which means that the Python will no more throw me error if I continue working on different blocks of the code. I'll come back to it. I'll just mention else over here, else. Sorry, you're not eligible for the scholarship due to lower score rank, or due to lower score. Okay. So this is how if elif can work. Now let us go back to our if condition. Now we will try to nest it. Now we will check whether the activities were performed or not. So if the student is into activities, we'll give congratulations, you're eligible for the scholarship. Uh, Over here, we will have another else block, which is again the part of the nesting only. Sorry, you're not eligible for the scholarship due to lack of sports participation. So again, I'll add a debugger on line number 8, just to demonstrate to you how the logic of the nesting loops are supposed to work. Again, I'll click on run and start debugging. I'll go to my debug console meanwhile. Now on the terminal, enter your scorecard between 0 to 100. Let us say I have received 60 marks, and yes, I was into sports. So now we are into the debugger. On line number 8, if the score is greater than or equal to 85, we should enter nesting, but in this case, it won't. That's the expected behavior, and we see that it directly goes into the else block of the first nest and simply give the output as okay. Let us try to add print statement in front of it, and let's try to rerun. Let us say 60. Yes, I was into sports, and it goes into the else block and prints the statement, sorry, you are not eligible for scholarship due to low score. Now again, we will try to run this with the logic of having score greater than 85 for now. Okay. I'll just rerun the code and enter a scorecard between 0 to 100. Let us say this time we go for 90. And were we into sports? Let us say no, we were not into sports. When we hit enter, it checks this logic, and you see how now this code entered the second layering of our decision making. Now again it is at a second level of if else block, and if the activities are one, congratulations, else it will print sorry, you're not eligible due to lack of sports participation. So I hope by now you have a fair idea how nesting is supposed to work. So once again, if we run python sample.py, we give a value of 88, we give viewer into sports, congratulations, you are eligible for the scholarship. So this is how we were able to demonstrate that just with two layers of logic, we were able to make a complex structure, such as to give a scholarship to someone based on their scores and activities. Next up, let's talk about chained conditions. These are logical operators like and, or whether to combine multiple conditions into one, right? So let's take an example for it to begin with. Whether a customer qualifies for a reward based on their purchase amount and membership status. Okay, so let us say if the purchase amount is greater than 5,000 and the person is our prime member, in that case they will get a reward, else they'll simply not get a reward. So by now we already understand how the logic of and or gates is supposed to work. So and will only qualify if both the conditions hold true. We also learned it in our previous sessions while talking about bitwise operators, how the and or logics work over there. Let us go ahead and again try to implement a code and see how we can use combined logic statements. So for now, I will create purchase amount. Let us say I will keep it as 5,400 rupees for now, and membership status as true for now. Okay, this is where we will implement the logic. If purchase amount is greater than 5,000, uh, and we will add membership status. Now this is a smart way to use Boolean logic that we need not explicitly mention equal to uh, true over here. Python can also understand if we simply mean and membership status. It will by default understand that if it is true, only then to proceed. But if you want, you can at this point simply keep this, that if the purchase amount is greater than 5,000 and the membership status is true, in this case we will print you get 10% or you, uh, you get a discount, or let us say you get a reward. We'll simply go to the else block. We'll print you do not get a reward. Now I'll not debug at this point. We will simply run python sample.py, and if we run it, by now you should have fair understanding of how this code is supposed to work. Line number 1 takes input variable as integer. Line number 2 takes input variable as a boolean. Line number 3 is nothing but an empty space. Line number 4, if the purchase amount, this is where the condition is checked. Now this is a nested, or you can say a compounded statement, right? Where we are combining two different logical statements both in one. Ideally, if you want to imagine it, this can also be understood as a nested if statement. It still works. So I'll demonstrate it to you, but let us first run this logic and then try to understand how it's supposed to work. So now I will hit enter, and you see you get a reward. As soon as I change this value to 49, even I go till 999 as per our logic, save, and I'll run this code once again. Let me clear the terminal. If I run this code once again, you see you don't get a reward. Now, as I mentioned, it is nothing but comparable to double if loops, or let us adjust the indentation. And if I raise the value greater than 5,000, you get a reward. So you see how basically combining statements can help you write more sophisticated and cleaner code. Uh, It just helps you write your nested conditions based on and or logic. Now, before we move on, here are some best practices that one must follow while writing conditions. We should always make sure that the variable names that we use are self-explanatory. As you might have seen, I chose variable names such as the score or membership status or purchase amount. Just by reading the name of these variables, they are self-explanatory to anyone, even who someone who is alien to this code. They might, if they understand English, they should be able to understand what this code is trying to say. So always remember, rather than using a variable name such as x equals to y equals to, uh, which is ambiguous in its way because the characters don't make meaning to itself, we should make sure that we name our variables in a way that the code becomes more readable. The other thing that we can pay attention to is to break down our conditions into smaller and readable parts. How this helps someone is, imagine writing a story with complex and difficult vocabulary of English. This limits the readability based on certain skill set and the experience level of someone to read English. Compared to, if you are a good writer, you can also write good things with simple English. Similarly, if you are a good developer, if you have learned your algorithm well, if your logic is crystal clear to you, it shouldn't be a problem to break down your complex conditions into smaller and readable parts such that there is no complexity in a given amount of frame to analyze and understand based on your code. And third and foremost thing that one can do is to keep on adding enough comments, making sure that your logic, especially the nested conditions, are very well explained. Now let us try to look at some real world applications of decision making in Python. The very first example we will understand is ATM systems. Now we have already discussed this in the session itself, that imagine how uh, such a now imagine such amount of security can be compromised if we allow the debit cards or the ATM cards to be used without pins, right, without any validation to it. So this is where the logic of decision making comes into picture. We apply the logic that if the pin which the user has entered right now, maybe using an input statement, if it compares to the pin stored in the security database, if it matches that, only then you're allowed to do the transaction. Now, the second example could be the e-commerce platforms where we have to apply discount. Suppose that we have to make a decision whether uh, the person should be given discount on certain membership, the person should be given discount on certain purchase history. That's where we can use the decision making. Let us make it even more evitable by understanding one example, that whether someone should uh, carry an umbrella or wear sunglasses or wear a jacket based upon the weather. So as you can see in the code, if the weather is sunny, uh, this is where the logic of wearing sunglasses should come into picture. Where else if it is rainy, so it goes into the if else elif logic, that now it is better to carry an umbrella. But if both the conditions, if sunny and elif rainy are not met, which means it is a weather of winter and it is a good time to wear a jacket. So let us summarize what have we learned. We went through the if, elif, else statements. We saw how nested and chain statements are supposed to work. We also quickly grasped how to write cleaner and better readable codes, which comes under the best practices to write a code. We learned how to make decisions based on if, elif, else statements. Now let us talk about something that makes programs even more efficient and help us solve repetitive automative tasks, which is known as loops. So why loops? Imagine you need to print hello world or any amount of statements 100 repetitive times. Imagine, would you spend writing 100 print statements even if you have to do copy paste, or is there a smarter way? Of course, there is loops can help us do this task easily. So the very first statement or the very first loop that we will try to learn today is for loops. Let us start with for loop. So these are perfect when you know exactly for how many times you want to repeat something. Let's try to analyze the syntax for writing a for loop. As you can see on the screen, the code snippet is for item in sequence, and the hashtag part explains the for block. Okay. So imagine we have a list of items. Now we want to iterate exactly the same number of times compared to the number of items in the list. So which is where we can use for statement. Let us go ahead and try to run one example around it. Let us say we have a shopping list, which is say apple, banana, and carrot. This is something that we are trying to buy. And we will say for item in shopping list, for now we will keep it very simple just to print an item, right? Now if we try to run Python sample.py, hit enter, you see sequentially the code runs for 3 different times depending upon the size of the list. If we increase a list little bit more, such as with date and eggplant, and we try to run it once again, let me clear the terminal, python sample.py, you see the list, the size of the list dynamically affects our for loop because we are looping into exactly the number of items in the shopping list. So this can be really helpful to do repetitive tasks. Imagine having a list with more than 10, 100 and thousands of items. How much amount of coding effort or monotonous effort can a for loop save rather than printing again and again the items in the list compared to making your list more dynamic in printing examples, right? For example, if you have list of 100 items, even if you write a code to print items on each index, tomorrow if I have to reduce or increase the number of items in my list, I also have to manipulate my code in a way that I have to adjust the print statements written. Now, these are few examples how repetitive tasks can be extremely managed with greater efficiencies in Python. And just like that, we loop through every item in the list. You can also use for loop with range function to repeat actions a specific number of time. Now let us try to understand that, for an example, if we do not have a list to iterate in, but certain range to iterate in, which is where the range function will come into picture. So let us say for I, or let us say for item in range. So range function, if we try to understand how range function works, we will realize that range function has a start, stop, and step as an optional parameter. Now the start function tells from which integer value or which index or which number we start this range from. Stop tells us which is the limit at which we should stop, and step tells us how much gap we should keep between each of the interval, right? So for example, I'll tell you, if we have to uh, start between 0 to 11, for example, suppose if I need to print 10 times, so I'll run it something like this. So for I in range of 1 to 11, I'll say print item, and if I try to run this code, you see we start printing from 1. Let me also help you debug this code once again. If I try to run a debugger on it, you see we are on line number 2, which is our first time we are hitting this for loop. As we go in, the item, which is the placeholder variable or the temporary variable name for this loop, it currently holds or has a value of item is equals to 1 as an integer. Now, if I run this, you see in the terminal 1 is printed. and the code loops back to the previous statement or goes back to the start of the for loop, and this time it again increments because of the range function. Now, as we have not defined step, by default range function takes step as 1 as a default value. Now if we go in and if we see, the item value has incremented to 2 now, and it is printed and so on. Now let us try to go ahead and introduce a step of 3. And now let's try to run this code once again. You see, for the very first time, the value again will be by logic item is equals to integer 1, which is printed. Next time when it goes to the start of this range function, it will take a step of 3, which is why now the value shifted from integer 1 directly to integer 4 because of the step 3. And as expected, the next step will lead us to value 7. And as expected, the next would be 10. And once we have 10, now if we increment, the value will be 13, which is of course not less than 11. Hence the printing will stop over there. Now let's talk about while loops. These are great when you want to repeat something until a specific condition is met. Now the syntax is of course on your screen. We simply mention while the condition is true. Now, as mentioned in the previous episode also, that uh, when working with Boolean conditions, we need not explicitly mention equal to true. We can simply write while condition colon. The Python will automatically understand that until the condition is true, we keep on executing this code. Now let's try to take one code example and see how while condition works. Let us say we have an integer or a variable count with the value as 0. We will mention while count, which is our variable holding an integer 0, while count is less than 5. Okay, so if you can understand the syntax that we just talked about, this highlighted part is that condition, right? So while this condition is true, while count is less than 5, we keep on printing count. And on line number 5, what we are doing, we are smartly incrementing count with +1 each time. This is also equivalent to count is equals to count +1. Now the smart way to write it is in a shortcut is count is incremented by 1. So as you can understand, even before we run this code, the logic is line number 1, count will store a value of 0. Line number 3, we will hit the while loop. So is 0 less than 5? Of course it is. We will print it. We will increment it. Now the count is 1. Is 1 less than 5? Print it. Is 2 less than 5? Print it. Is 3 and 4 less than 5? We keep on printing it. But is 5 less than 5? No. So according to our understanding, we should see 0, 1, 2, 3, 4 in the output. Let us try to run this code now. And as I explained, you see this is the output. Now, one word of caution is that whenever we are working with while loop, make sure that you have good termination logic, else these loops often turn to hit infinite barriers such as infinite looping. For an example, while condition count is less than 5, keep on printing count. If at all this code is run, we will end up into something known as infinite loop because count currently holds a value of 0 and there is no provision in the code to make count bigger than 5 or greater than 5 at any instance. Hence, this code will keep on running till infinity. So even if I try to save this and try to run it, you see that the printing has started and 0 is getting printed infinite number of times. Even if I scroll down as much as possible, this printing will never stop. The only way to stop it is using hard stop, which is using Control C and keyboard interrupt, or completely shutting down your system. Sometimes you need to control over your loops. This is where break, continue, and pass come into picture. Now, here's what they exactly do. Break is used to exit a loop immediately. For example, if I have to search something and if I found it, there is no sense in running that loop, right? Which is where break comes into picture and I can simply break out of the loop. Whereas continue is a little opposite of that. It helps us skip the looping of the current iteration and move to the next one if certain condition is met. Whereas pass, it does nothing. It is just like a placeholder. So if you have observed carefully in few of our previous lectures, we have used pass statement and it was also explained there. Now let us go ahead and try to run it in our code. Let's take for an example for loop with a range function. Now we know that for number in range of 1 to 10, we will start the looping from 1, we will go till 9. If the number is equals to 5, we have a print statement just to explain you that we are hitting the this particular block, the nested block. And when we hit break, you see the printing will stop on 5 itself. Ideally, the first for loop should go till 9, but the break statement will eliminate the looping structure and break the loop out. Let's try to run this code once. Okay, let me first save. As you see, number 1. Now, let us also understand why it is skipping an even number is because if number modulus 2 is directly equal to 2 is equal to 0, which means that it is completely divisible and there is no remainder. In that case, we simply skip an even number and use a continue statement. What continue statement does for here is that it tells us that okay, we have met a certain condition, but we don't want to exit the loop, or we don't want to do, or maybe we want to do something else, so keep on continuing for now. Okay, so while running, uh, we printed number 1 on line number 8, which means that number 1 didn't meet the condition if number equal to 5. Number 1 didn't meet the condition that dividing it with 2 resulted in a completely uh, satisfied, or dividing it by 2 didn't result in any remainder. Uh, okay, so we will take a retake of this part. I hope that's okay, right? Okay. So let us try to understand how break continue statements work with the help of this example. So the very first loop is for number in range of 1 to 10. Now here we by default understand that this number will loop from number 1, 2, 3 up till the digit 9. If the number is equal to 5, which is the nested condition on line number 2, if this is met, our code will enter line number 3, which is a print statement, line number 4, where the break statement is mentioned. And break, what does it do? It helps you break out of the loop. So ideally, despite the first loop should work from integer 1 till integer 9, the looping will exactly stop on number 5. If you proceed on line number 5, we have if number modulus 2 equal to 0, we will simply skip an even number. So values like 2 and 4, 6 and 8, so on, will hit this condition. And here we have a continue statement just to explain what continue is supposed to do. So suppose if we have met a certain condition, and at that condition maybe we want to do something special out of it, or maybe we just want to store it somewhere, but we don't want to stop the loop, we want to continue with. So this is what continue will do for us over here. It will help us identify that okay, we have hit an even number, we recognize it, maybe we do something special with it, but we keep on continuing further. So that's the difference between the break and continue. And on the line number 8, if you see, if both the if number equals to 5 and number modulus 2 equal to 0 is not satisfied, line number 8 will simply print the number for us. Now let us try to hit a debugger and try to understand how this code will work. So We have started the very first loop, which is for number in range of 1 to 10. The number for now is equals to 1. So the first nested loop will not work. The second nested loop will also not work. It will simply print the output for us. So if we see the output number equals to 1 is printed, we enter the next iteration. Now the number is 2, hence the number models 2 will activate, and this is an even number. So we'll print that we have found an even number, and you see how continue will help us proceed with the looping. Now we go back, we increment the number to 3, number is not equals to 5 also, neither does modulus 2 equals to 0. We will print the number as a general one. We'll go ahead and 4 will skip again an even number. We'll go ahead, now since we have found number equals to 5, the first if loop condition is met, this is where the breaking logic will come into picture, and the code will simply break and run no further. So this is how break can help you break out of the loops, whereas continue can help us to identify certain particular conditions. Maybe we want to do something around it, but keep on continuing the loop. So continue will help you continue the loop even after the identification. Uh, are we doing best practices? Because in this notes there is range also. Before we move on, here are some best practices for writing loops. To avoid infinite loop, be careful in managing your condition such that your while loops are specifically handled to make sure the condition at certain point does meet it. Keep your loop clean and efficient so that your loops run with the most clean and the shortest possible paths. And again, the golden rule is to always use comments whenever possible and necessary. Loops are everywhere in the real world. Let's try to relate what we have learned with some real world examples. Let us say we have to generate a report and we have to iterate over different rows to create a summary, right? So what we can do is we can simply take the data, which is our report. We can try to run it line over line, or let us say rows over rows. And for each row, we can read the data and generate a summary around it. Next could be automating tasks. Imagine that we run a business where we have to run maybe multiple ad campaigns, we have to send bulk emails or process multiple files. So in all of these conditions, we can use while loop. You can use the for loop, that for the customer in the list of customers, take that customer, see what type of customer it is, and send an relevant email to that customer. Let me make a relatable example for you. A for loop is like reading every page in a book, right? You know exactly how many pages are there, and then you go through each page one by one. Whereas a while loop, on the other hand, is like playing a game until you lose. So there is a condition that you don't know exactly how many iterations of this game will work. Maybe you win after third iteration, fifth iteration, or maybe after 100th, or ongoing until and unless you ever win this game. So while loop can be understood with this analogy, whereas the for loop works with, you know exactly where the condition can stop, and you just go iterating one by one. So for summary, we have explored for and while loops. We understood how loop control statement works, such as break, continue, and pass, and how powerful certain functions like range can be when introduced and combined with for loops. We have discussed how loops help us automate repetitive tasks. Now let's take things a step further and learn about one more powerful tool in Python: functions. Functions are like magic wands. They make your code modular, reusable, and so much easier to understand. Let's explore how to use them. First of all, why function? Imagine having a recipe in your hand and trying to build it every time you want to maybe eat it, right? Whereas compared to creating a predefined mix, a formula, and storing the recipe into a ready-made box. So every time you have to just take the input vegetables, and using this reusable formula, or maybe like a reusable machine which can help you mix these things correctly and directly present you with the output, you have saved yourself all the manual efforts and put the repetitive tasks to be done by the machine. So we can create different machines for different recipes, right? Today I want to have maybe a salad, so I can define what will be the input to my salad and explain it to this machine. I can teach the machine one time to how to cut and how to mix it and how to use a bowl to give the output. Similarly, functions can be used to write code one time and make it modular and reusable. I'll just explain once that what exactly is to be done with the inputs and how to give back the output. So understand functions like machines which do repetitive tasks. Imagine you're writing a program to calculate the area of rectangle multiple times, maybe with using different lengths and breadths. Why would you rewrite the formula over and over? No way, right? Functions let you define the formula and reuse it whenever you want it in your code. So in short, functions can help you program modular, maintainable, efficient. Let's start by learning the syntax on how to call a function. So the very first thing is that we need to define the function name and the amount of parameters it takes. Let us start by learning how to define and call a function. So what you see on your screen is the syntax of a function. Def is a keyword which is reserved in Python to explain that we are about to write a function's name. So def followed by the function name with a round bracket. Inside round bracket, something goes as parameters, which we will discuss soon, is mentioned with the colon. And again, functions also follow a special indent. So make sure that you follow the indentation to write the function block inside the function itself. In the very end, you see a return value, which is again used to return whatever is the output created by this function. So now let us go to our VS Code and try to write a function which helps us return the square of numbers. So let us start by taking a number, could be anything like 3, and create a function. Let us define a square function which takes any input, could be let us say number for an example, and what it returns is number multiplied by number. This is the logic to create square. So let us say we have a list of numbers such as 1, 2, 3, 4. We want to find square of each number in this list. So for num in nums, print square of num. So if we try to run this code once, let us try to run it. You see, we are able to print the square of each of this number just by writing once how the number is to be squared. The logic is written once in a function by the name of square. Now let us talk about arguments and parameters. So parameters are like placeholders of the name of the variable, which could be anything, right? And arguments are the actual values for the placeholders. Let us understand how it works. Let me create a function which will greet. Now, whatever I mentioned over here, name, this is known as the parameter. It is nothing but a placeholder. Name could be anything. But for this function, the logic is to return hello followed by the name. And this is the complete definition. The function is defined. Now, when I call this greet function, and let me say greet Alice, and let me say greet Bob, what we will notice is that the values such as Alice and Bob's are the arguments. So sometimes it gets a little confusing for the learners to differentiate between parameters and arguments. So remember, parameters are just placeholders and arguments are actual values. So P of parameter for placeholders, A of argument for actual values. So let us try to run this. And as you see, okay, now if you see, the return statement is just returning the value back. So we have to wrap it under a print statement to get it on the terminal. Now when I run this, you see we have the output printed on the terminal with hello Alice and hello Bob. You can also expand your knowledge to use default parameter values in Python, which is more flexible way of defining certain parameters which might have a default value. For example, let us say define coffee as a function which takes sugar. Now sometimes uh, the value of sugar could be 2 and the value of milk could be 1, which is maybe the amount of, or maybe say 100 ml, and sugar is 2 tablespoons. Now what we are doing over here is we are defining certain parameters, but we are making them as an optional parameter. For example, we can call coffee as a function without passing any parameter. We can pass coffee with passing 1 tablespoon as a parameter, or we can pass coffee and explain that the milk should be 200 ml, or we can pass coffee with sugar is equals to 1 tablespoon and coffee and milk is equals to 250 ml. So remember that both sugar and milk are optional parameters, because if we do not pass them, the function uses the default value of the parameter. If I try to run this, you see I am printing coffee with 2 tablespoons for the execution on line number 5, which didn't explain what amount of sugar and what amount of milk should I use. It used the default values. Whereas coffee with 1 tablespoon and default value of milk, whereas coffee with default value of sugar and customized value of milk is shown in our output. Sometimes you don't know how many arguments you will pass, and sometimes you don't know. Uh, okay, so let me check if there is any slide for this next one, arguments and quarks. Should I continue? The If no argument is provided, the function assumes the default value. Isn't this handy? Sometimes you don't know how many arguments you will need to pass. This is where the concepts like args and quarks come into picture. So args or args, they allow you to pass a variable number of arguments which will be needed. Let us say, for example, I'll create a simple function which will sum different numbers. So I'll say some numbers, and right now I'm not sure how many numbers I need to sum. So with the syntax of asterisk args, we explain the function that we're going to use args, and by default it understand that there'll be multiple iterations coming into picture. There could be n number of parameters and the arguments, n number of arguments which are values which can come into the scenario. So let us take print for an example, sum of numbers. Now this time we are passing 4 different values. And what is happening inside function is we are using the default sum function to sum all the values passed. Now by default 1 plus 2, 3 plus 3, 6 plus 4, the output should be 10. And if we try to run this, Okay, let me first save this and try to run it. We get output as 10. So similarly, quarks allow you to handle different keywords in arguments. For example, when we shift our understanding from numbers to keys and values, for example, we have to display information for n number of keys such as name as Alice, age as 25, city as New York. So if I'm passing n number of arguments with different values, I use a function to display information for it. Since it is a dictionary, we can iterate using dot items. So for the key and its value in items, I'll be printing key and values. So for example, if I run display information with 3 values, and if I run display information with just 2 values, and maybe a completely different variable such as country is equals to USA. And now if I try to run this code, you see each iteration handles the dynamic nature of keys and values by quarks. So this is really helpful when we don't know, or the number of input parameters or arguments is not defined. It can vary, which is where the concept of args and quarks definitely help us ace our game. Scope and limitation of variables. Next, let us talk about scope. Scope determines where a variable can be accessed in your program. For an example, a variable can be created inside a function, so that results in a local variable, whereas a variable can be declared out of the function known as the global space or a global variable. Okay, we'll switch back to the VS Code then. So to understand the meaning of local functions or the local variables, let us try to read this example. So we have a function known as show message, and the show message has a variable on line number 2 that hello from the inside of function. Now, if I try to run this code, let me show you the execution with the debugger. I'll try to run it. We have hit line number 5, which is that we are going to hit a show message function. If we enter that function, now we have the definition of message, which is a string. So the print message will work over here because this function knows exactly what message variable is all about. Now the message is printed. The terminal has hello from the inside of the function. We go to the next line, and now if you see, if we try to print it, this should throw an error, which is name message is not defined. So this is a name error because the scope of the variable message was strictly inside the function itself. Hence, this is known as a local variable. Now let us look at a global keyword example. Suppose on line number 1, we are declaring a variable count equals to 0, and on line number 7, we call a function increment. In this function, we are using a keyword known as global, which helps us expand the scope of this function to use global variable count. So even if I print count, comma, this is from inside the function print count, this is from outside the function. Let's try to see how this iteration of code will work. So as on line number 8, we hit the function call. Let us go inside the function. Since we have declared count exactly on the line number 1, And by global space, the variable name, now the increment function knows the value of count, what it is supposed to be, since it is a global variable. As we print, you see 0. This is from inside the function. Inside the function, we are modifying the variable. Now remember, since this variable is being used from a global space, any modification done inside the function also impacts in the global level. Now if we increment the value of count by 1 and then go to line number 9 and we try to print it, you see now the value of global variable count has become 1. Always remember that while using global variables, we should use it with, okay, use global variables sparingly as they can make debugging a little complex and challenging. Let us understand some benefits of functions. So let's quickly recap why functions are so awesome. So functions help you write modular codes, also known as modular programming. So modular programming helps you break down large complex codes into smaller and manageable pieces. Whereas the functions also are used in reusability. So we write once and use multiple times. Functions can also help us improve the readability. Since functions make our code organized, it makes it more clean and easy to understand and read. So with functions, you will work smarter, not harder. Before we move on, here are some best practices for writing function names. We should always remember to use meaningful names for functions and parameters such that they are self-explanatory. The logic which was explained to how to use best practices for variable names also apply equivalently for function names. We should keep function names short and focused on tasks. And the global rule is always to write commands to explain the complex logics. So good practices make a good programmer, and a good programmer writes modular, efficient, and simple code. Let's look at some real world applications of functions. For example, a financial application can calculate monthly payment based on loan terms. Let us understand a function which takes principal rate and time and returns the interest value. So irrespective of what will be the principal amount, what will be the rate, and how much time intervals are left, we can always reuse this code to calculate payment. Similarly, web applications handle form submissions such as validating user inputs and storing it in database by using repetitive function calls. For example, if we have to log in into our account, we can use a same logic of login by defining a login function, and we can define how to sign up a user, how to every time call the same database queries but with different variable inputs. So that's how web application handle different form submissions through functions. Relatable examples. Think of functions like recipe cards. Each card explains a specific process and you can reuse it whenever needed. And what about default parameters? They are like ordering coffee. If you do not specify sugar, there is a default value, could be say no sugar, or could be like the specified default amount. So let us recap what we have learned. We understood how to define and call functions, the importance of arguments, and how args and coargs can help our life while maintaining the dynamic nature of variables or parameters. Okay. The role of scope of variables, how we can define a variable inside a function known as local, or we can use global variables. In we will dive into data structures such as list, tuples, and more. Functions and data structures together. That's where the real magic happens. So see you there. Thank you.